Good morning, students. Today we'll discuss boiler problems and softening methods. Boiler corrosion, caustic embrittlement. So, boiler corrosion is categorized into two aspects. One is due to presence of dissolved oxygen, dissolved carbon dioxide, and dissolved mineral acids in the water, and one is because of presence of NaOH causing concentration cell in that boiler wall act as anode and gradually corrosion takes place, that is under the heading caustic embrittlement. So we will discuss first dissolved oxygen, how dissolved oxygen is responsible for boiler corrosion. It is the chief source of corrosion in boilers and ancillary equipment. The concentration of oxygen in boiler water should be below 0.05 ppm for low pressure boilers and less than 0.01 ppm for high pressure boilers. When the water containing dissolved oxygen is heated in the boiler, the free gas is evolved which corrodes the metal parts under the conditions obtaining in boiler. The solubility of a gas is directly proportional to pressure and inversely proportional to temperature. That is Dalton's law and Henry's law. These two principles are made use of in the design of mechanical deaerators. In mechanical deaerators, dissolved oxygen is removed by injecting hot feed water as a fine spray into a vacuum chamber heated externally by steam. So the reaction show how iron gets corroded in presence of dissolved oxygen. To reduce or remove the possibility of corrosion by dissolved oxygen, many times hydrazine N2H4 is extensively used to remove dissolved oxygen in high pressure boilers. The pure compound is an explosive inflammable liquid, boiling point 113.5 degrees Celsius, but the 40% aqueous solution used for water treatment is quite safe to handle. The important advantages of hydrazine treatment is that combination with oxygen does not produce any salt. If we add N2H4 hydrazine to the water which contain dissolved oxygen, it gets converted into nitrogen and H2O, removes the dissolved oxygen and possibility of further corrosion of boiler. The molecular weight of hydrazine and oxygen are the same, so that complete elimination of 1 ppm of oxygen would require only 1 ppm of hydrazine, which is 1/8 of the necessary concentration of sodium sulfite. The amount of hydrogen added must be closely controlled. Any excess reagent decomposes in the boiler, liberating ammonia, that is thrice N2H4 is equal to 4NH3 plus N2. Dissolved ammonia can bring about corrosion of some alloys such as copper alloy condenser tubes. So this diagram is a diagram of mechanical deaerators in which an arrangement is there, which is water at a high temperature is sprayed through vacuum, and during this process dissolved oxygen and dissolved carbon dioxide and other gases removed from water. Second, some information regarding dissolved mineral acids. How dissolved mineral acids are responsible for corrosion. Some inorganic salts like magnesium chlorides and calcium chlorides are also corrosive agents. MgCl2 hydrolyzes completely at 200 degrees Celsius, producing hydrochloric acid as follows. The reaction is MgCl2 plus twice H2O is equal to MgOH twice plus twice HCl. CaCl2 also undergoes hydrolysis but to a lesser extent. At 600 degrees Celsius, its hydrolysis is about 25%. Salicylic acid catalyzes the reaction so that in water containing silica, appreciable quantities of HCl may be formed at lower temperatures. Fe plus twice HCl is equal to FeCl2 plus H2. FeCl2 plus twice H2O is equal to FeOH twice plus twice HCl. Hence, even a small amount of MgCl2 can cause considerable corrosion of the metal. If the amount of HCl formed is small, it might get neutralized by the alkalinity present in the water, but otherwise it should be neutralized by the addition of alkali. Corrosion of boiler because of dissolved carbon dioxide. Water containing bicarbonates release CO2 on heating. The CO2 is dissolved in water forming carbonic acid. This produces intense local corrosion called pitting. CO2 along with oxygen in water can be removed by mechanical deaeration. The reaction is CaCO3 plus CO2 plus H2O is equal to CaCO3 whole twice. CO2 plus twice NH3 plus H2 is equal to NH4 whole twice CO3, ammonium carbonate. If some oxygen is also present in the condensate, the ammonia may attack the condenser tubes made of copper. Hence, a safe limit of 10 milligram of ammonia per liter of the condensate is prescribed. Caustic embrittlement is because of presence of NaOH, and this NaOH is there in water. When we use lime soda method, the soda Na2CO3 gets converted into NaOH in high pressure boiler and responsible for caustic embrittlement. So in this caustic embrittlement, because of the improper mixing, center part of the boiler vessel has comparatively less concentration of NaOH as to that of cracks and corner, leading to formation of concentration cell, and in that reactor wall acts as anode. Caustic embrittlement is a form of corrosion caused by a high concentration of sodium hydroxide in the boiler water. It is characterized by the formation of irregular intergranular cracks on the boiler metal, particularly at places of high local stress such as rivets, scums, bends, and joints. Na2CO3 plus H2 is equal to twice NaOH plus CO2. By this chemical reaction at high pressure boilers, soda gets converted into NaOH. NaOH reacts with iron forming magnetic oxide and hydrogen. Na3PO4 is an effective conditioning agent and also is over 300 times as effective as Na2SO4 is suppressing embrittlement. Caustic embrittlement may also be prevented by adding lignins or tannins, which help in blocking the infiltration of NaOH through the hair cracks. Addition of NaNO3 neutralization of excess alkali is also used to prevent embrittlement. So this is the photograph showing how different type of corrosion causes boiler metal brittle or sometimes get corroded, cracks and leakages are there. So that is information regarding boiler corrosion. In the next lecture we will discuss next topic of unit number 2. Thank you.